yesterday, what we have done is that we have done the integration of the trivial functions. Okay, and I did tell you that I will not memorize the thing because I only memorize the differentiation of it. Okay, so what we do is this. Now, do you agree that I just know these three, I can do the reverse? Alright. When I integrate cosine, what do I get? Sine. When I integrate sine, what do I get? Negative cosine. When I integrate secant, what do I get? I'll get tangent. Okay. So this is how I do it. Alright. And I need to bring attention to the next formula that we have also. Okay. Now I'm just going to go through one of the examples again. Okay. If we want to integrate this, we will have tangent. Then I must divide by 3, right? Remember, I must divide by the differentiation of the inside. Okay, then I must plus what? See, now if you think about it, it's actually the same as what the textbook has suggested. You put 1 over A. 1 over A is actually divided by A. It's the same thing. So it is okay to leave like that also. It doesn't matter. Okay? Then, can I bring your attention to the last question that I've done yesterday? The integration of tangent square x plus 5 pi dx. Now, you will see that in the ruler, there is no integration of tangent square at all. Okay, so we need to use the trivial identity to change it to secant square. Then we can integrate. You understand? We can only integrate this, and this. Understand? If not, we cannot integrate. Everybody clear with what I'm saying? Okay, good. Now, next, I'm moving on to example 11. That's where I stopped, right? So I'm moving on to example 11. Okay, let's take a look at example 11. They want to find this. What do you mean by this, class? You differentiate the inside, right? So this one I must use product rule, right? Okay, let's take a look. I fix this. Then when I differentiate this one, do I get cosine x, right? Okay. Then I plus. I fix this. I differentiate x, I get 1, right? So actually it's just x cosine x plus sine x. This will be my differentiation. Agree, class? This will be my differentiation. Everybody okay? Alright. Now, some people after they do so much, right? They differentiate, they also go and plus C, no need differentiation got no C one, you understand? They do too bad already, everything go plus C plus D plus whatever. Okay, differentiation got no plus C. Okay, now next thing, they say this. This one is the one that I'm worried about. They say hence find the integration of this. Okay, find the integration of this. Now, this is our mission. We need to find the integration of this. This is a very common O-level, more difficult question. We need to shift here and there. Okay, now, can you see that when I integrate this whole thing, then I will get this? This is only part of this. You can see it. So there is a problem, right? Do you get what I'm talking about? I must integrate this whole thing, then it will be this, you know. But this is just part of this. Can you all see what I'm talking about here? Okay, so what do we do? Don't panic. I'll show you a way, okay? When we integrate this whole thing, I will get, correct? When I integrate this whole thing, I'll get this, okay? Plus C. Everybody okay? Now, when I integrate this whole thing, I can integrate them separately, right? All of you look up, huh? That means I integrate x cosine x dx plus integrate sine x dx will be x sine x plus dx. I can integrate separately the function, okay? Now, this one is what we want to find. So, this one will remain here. Okay? X sine x plus c minus the integration of this, right? Can you see I'm doing some algebra here? I bring it to the other side. Okay. X sine x plus c minus. Now, when I integrate sine, what do I get? Negative cosine. Can you see what I'm talking about? So, this is actually negative cosine x plus d, correct? I must have another constant, ma. Am I right to say that? Okay. So, this will be x sine x plus c plus cosine x minus d, right? Okay. So, I will get x sine x plus cosine x and plus f lah. Where actually my f is what? C minus D. You don't need to put C minus D minus Z kind of thing. Just let it be F. Can you see I skip the letter E again? Can you see it? I don't let it be. So, when I integrate this, right, I will get x sine x plus cosine x plus C. So, that's how we do it. Can you see what I'm talking about here? Can you see what I'm talking about here? They ask you to differentiate this, then you get this. That means when I integrate this, I will get this, right? But they want you to find this. This is our aim. That means it's only part. So we got to do it differently, shift over, and we do accordingly. Can you see we are still applying the same concept? But just that we got to move things here and there. Is everyone clear with what I'm saying? Okay? Definitely you can integrate sine x, ma. Correct now. Don't say you don't know how to integrate sine. Then it's very sad. You understand what I'm talking about, huh? Can or cannot? Can or cannot? Can, huh? So this is the last example of your trigo differentiation. I mean integration. Are we okay? Are we okay so far? Yes, huh? Okay, good. Now, next, we are going to do the homework for the integration of trigo first. I don't want to bring in EX. Can I just go through the main thing of EX and ln first? Then after that I'll do the thing. The examples I will not do, I will do it the next lesson. Because I think with so much time I cannot be doing the homework. All of it. You understand? Okay, come. Now, so this is the first set that we have learned. Now, what is the second set of things that you will learn? Can you look at page 107? This is the easiest one. When you integrate EX, you will have EX plus C. Can you see it's the same? Remember when you integrate, when you differentiate EX, it's also EX. So when you integrate EX, it's also EX. Okay? Now, what if you integrate you'll get 1 over A E AX plus B plus C. That means, can you see, you bring the same thing, then you still divide by the differentiation of the top. Can you see what I'm talking about here? Now, I will give you an example. You don't have to worry, okay? I'll give you an example later. So, these are the two that we need to know for EX. Are we okay? Alright, huh? Now, then we turn to page 108. And all of you turn to page 108. I have two more integrations. When you integrate this, it's just ln x plus c. Remember when I differentiate ln x, I get 1 over x. So it's the other way around. So what if I integrate 1 over x plus b? Now space, let me lengthen this. This will give me ln ax plus b, then you divide by the differentiation of the function. Do you understand what I'm talking about here? Then of course you must add a constant. Therefore we have a plus c still. So these are all the things that we have. Are you all okay? I will go through simple examples to illustrate this and this. The application part we'll do it later. Okay, Ken? Alright, so let's move on to the simple things first. Okay. Can we all move to page 107, example 12? Integrate the following with respect to x. Don't forget, after you put the integration sign, you must put dx. Okay? Now, if I follow the rule, right? All of you look up. I will write this thing, right? Then I will divide by what? Differentiation of the top, what is it? 3, negative 3. Then I plus here. So if let's say you want to write nicely, it will be like this, right? Can you see? Can you see what I'm talking about here? Can or cannot? Can, Okay, now, then we look at the next part. I'm supposed to integrate now, a lot of people say, oh, die. Don't know how to do this. I teach you first. You rewrite first. This one is actually 1 over e 9x minus 5. If I bring it to the top, it will be e minus 9x minus 5. Agreed? Okay, so what will this become? E what? 5 minus 9x, right? 2. I just flip the thing, okay? Can you see what I'm talking about here? Okay? So, when I am integrating this, the constant will remain. Am I right? Constant will remain 9 over 4. Then I write this down. Then I must put 1 over what? I must differentiate this. What does it give me? Negative what? 9. Can you see it? Then, of course, I must plus c. Okay, can you see this 9 and this 9 cancels off? So what does it give me? Negative 1/4. Okay, 10? Alright, now how come my answer is different from the textbook? The textbook is this. 8. Textbook is this, wait. How come the textbook is this? Is there any difference? Or they are the same? They are the same, This one is I put on top, right? Can you see this one they put below? If I put negative of this, I put it on top, is 5x minus 9x, right? I mean 5 minus 9x, right? So it's actually the same. Everybody clear? Do you understand what I'm talking about? Repeat, this is below, right? So if I put a negative, I can bring it to the top, right? Negative 5, negative 5 is positive 5, then minus 9x. Can you see? It's the same thing. Okay? Alright, now, next part. Can we move on to example 14? All of you look at example 14. Okay. Now, this one, if I were to differentiate this, is the same as I bring up the constant, right? Remember I told you? So, this will become what? 3 ln x plus c. Can you see? Everybody okay? Can, Okay, so next part. Okay, next part, Okay. You look at this. What is going to happen? What's supposed to happen? You look at this one. I'm using this one. So, what do I have? I'll have ln 2x minus 1, right? Correct or not? Then I've got to put 1 over the differentiation, right? What is it? What's the differentiation of inside? 2. Then I plus C. Can you see what I'm talking about? Now, is it okay if someone writes like this? It's also fine. It's just times a half. It's the same, okay? So, usually, what I do is that I always put a bracket in front. So that I remember I put 1 over something. So, what's the 1 over something is 1 over 2. Okay? So, it will be half ln 2x minus 1 plus C. Everybody okay? Everybody okay so far? Okay, now, last example that we have will be this. Now, you can take out the constant. Like that, easier to see, right? Can you all see it? Okay? So, this will be 2. Now, I always do this. All of you look up. Then you won't make mistake. You put ln, then it's 1 over something. 1 over what? You look. What's this? It must be negative 2, right? Then don't forget, must plus C. Understand? Now, can you see this one and this one is gone? So what do we have? Negative ln 1 over 2x plus C. Everybody okay? Everybody okay now? Can or cannot? So these are the basic rules that we have to integrate EX and ln X. Everybody clear? I'm going to repeat. EX, no problem, straight away the same. And this one, you just write and put 1 over something. Okay? Likewise, this one is just ln X. Then you ln that something 1 over the differential. So you will get the answer straight away. Everybody clear? So I just want to leave these 2 concepts with you first. Okay? So that, because you know why? For this one, right? Some of the questions are always linked to partial fractions. You got to link to partial fractions before you can integrate. If you don't put it in terms of partial fractions, we cannot integrate. You understand? So your partial fractions will come in. I don't want to go through partial fractions today. I want to do it next week. So that there's not so much info into your head. Everybody clear? So we have done trigo, EX, and the 1 over X. Are we okay? Can, Okay, good. So, what is the content page number now on your AMATS content page? Not like 16, okay? 16, today's date is the 8th. Exercise 16. This is bad. 16.2, right? Okay. Integration of trig functions. Alright. I know it's a lot, but no choice. You have to practice. Understand? Because trigo cannot do it. Then integration of trigo also cannot do it. Differentiation also cannot die. Nothing to do. Okay? So, exercise 16.2. I want question 1, 2, 3, 4, 5, and 6. Only 6 questions. Sorry, I'm going to take a look at the questions first. Isn't it wonderful? I seldom give 6 questions, right? I always give about 10, right? So since this is 6 questions, so it is actually a discount. A discount. No lah. I discounted 1 question one. So isn't it already a discount? Okay? Oh, you must thank me for that, you know. If not, you will eat the whole thing, you know. And the whole exercise don't even take up 1 page, my goodness. Okay? Don't care. My class very used to it. They should be getting used to it by now. It's already April. Usually they will say, "Are you sure that's all?" Because usually I write a lot. Okay? Alright, let's start. Because I need to get you familiarized with this. So everything except 7, okay? Everything doesn't mean you do only part A, It's So when you integrate 2, I will get 2x. Okay, then I have a minus. What if I integrate sine? What do I get? Negative cosine. Then don't forget the plus c. So it's 2x plus cosine x plus c. Now I want to highlight to you there is a possible mistake, though it's an easy question. Can you see here might have a mistake maybe? You forgot about the negative. Can you see what I'm talking about here? You have to be very careful. You cannot say never mind, negative or positive look the same. What rubbish is this? If you have negative 1, that means all people $1. You have plus 1, you have $1, you can buy things, you understand? It's not the same. Everybody clear? So got to be very careful. Okay, D. Integrate 3 secant square x plus 5. Okay, you integrate for me. 1 minute. This one is easier than the first one. Answer should be in 30 seconds. What should it be? 3 what? 3 tangent x plus 5x plus c. Everybody okay? Yes or no? Yes or no? Okay, good.